So you just finished taking test 2, part 2 of your calculus test, and let's go over it. You're going to grade your own exam. The first part of 1 is worth 10 points. Use Riemann sums to first estimate and then find the area under the curve of f of x equals 4 minus x squared on the interval from -2 to 2. We're going to estimate the area of the curve using 4 rectangles whose height is on the right of the rectangle. If you graph this, this is f of x equals 4 minus x squared. So this is a parabola where it is facing downwards and shifted up 4 units. You didn't need to know this, but this is what the graph would look like, intersecting at -2 and 2. We need to figure out what the width of each rectangle is going to be, and that is equal to b minus a all over n. So our b value is 2 minus our -2, and we're subdividing this, in this case, into 4 different rectangles, so divided by 4. So this gives us 2 minus a -2 is 4, 4 over 4 gives us 1. Since we're going to the right, then we're going to look at this, where we're looking at the height here. And so the first height is going to be at f of -1. We want to go in and we want to plug this into our equation, f of x equals 4 minus x squared. So 4 minus a -1 quantity squared is 4 minus 1, which is 3. Next time our rectangle is going to be when x is 0, so f of 0, the height is when x is 0. And so plugging in 0 into f of x, we have 4 minus 0 squared, which is 4. To get the height of the next rectangle, we're going to go over 1, which is when x is 1. When x is 1, plug it in, we have 4 minus 1 quantity squared, so 4 minus 1 is 3. And the last one, f of 2. Well, f of 2, I noticed that that's when x is 2, y is 0, so the height is 0 there. So to find the area, we're going to take the width, which is 1, times the height, which we just found for each piece. And so the area is going to be 3 plus 4 plus 3. All of this is 3 times 1 plus 4 times 1 plus 3 times 1. So I didn't write the times 1 for the width of the rectangle. And so you should have an answer of 10. Part B, it wanted you to use limits. So it didn't want you to use definite integrals. It wanted you to use the limit of Riemann sum. So we're looking at the limit as n is approaching infinity of our summation from k equals 1 to n of f of c sub k all times delta x. So in our case, delta x, well, it's equal to b, so 2 minus a, which is -2 all over n. So this gives us 4 over n. C sub k, and it told us to use right value on our rectangle, and I gave you that it was a plus k times delta x. Well, a in our case is -2 plus k times delta x, which we just found above, which is 4 over n. We want to look at what is f of c sub k. So what is f of -2 plus 4k all over n? So we're going to go back in and we're going to plug this in wherever we see an x in our equation f of x. And so this is equal to 4 minus this quantity, -2 plus 4k all over n, quantity squared. Okay, so if we distribute, we have 4 minus, and then -2 plus 4k over n, that quantity squared. If you distribute that out, you get 4 minus 16k all over n plus 16k squared all over n squared. So distribute our negative. Notice that our 4's are going to cancel, and so we're left with 16k all over n minus 16k squared all over n squared. So this is our f of c sub k value. Let's get a common denominator, which is n squared. So we're going to multiply this by first fraction by n over n, which would give us n squared. And in the numerator, we would have that 16 times kn. Okay, so now we're looking at this limit as n is going to infinity. Summation k equals 1 to infinity of this right here, which is our f of c sub k. And with a common denominator, we have 16kn minus 16k squared all over n squared. And then this is all times delta x, and our delta x right here is 4 over n. So all times 4 over n. So we can pull out anything in front of that summation that isn't have a term of k. And so I notice right here that we can pull out this n squared all times this n. So we can pull out an n cubed in front of that summation. We need to bring down the limit. And then notice that we can factor out a 16 here from both of those pieces. And this is going to be distributed, so times that 4. So 16 times 4, that gives us, that's in the denominator, that n cubed. That's going to give us 64. So we have 64 all over n cubed that we're going to pull out side of that summation. So now we are left with k equals 1 to n, which actually, that should be n, which is going to infinity because of our limit. And then we're going to be left with a kn minus a k squared. So you are given the summation formulas for the summation of k and the summation of k squared. So using those, we have a limit as n is going to infinity of 64 all over n cubed all times n. So the summation of k is from 1 to infinity is equal to n all times n plus 1 all over 2. Minus, and now the summation of k squared is n all times n plus 1 all times 2n plus 1 all over 6. And so notice those numerators and the denominator actually has things in common that we can factor out. I notice that we have an n here that we can pull out. I also know that we have this n plus 1 that we can pull out. And notice the denominators have a 2 in common. So we can factor out a 2 here. And so if we do this, we have the limit as n is going to infinity of this 64 over n cubed. And I'm pulling out this n times n plus 1 from the numerator all over, and I'm pulling out a 2. So if I do that, I'm left with here an n, which I'm going to want a common denominator. So let's call that n 3n all over 3. My common denominator would be a 3 there. And then over here, all we're left with is this 2n plus 1. So minus this whole quantity 2n plus 1. We want to distribute that negative. Notice over here, when we bring stuff down, 2 goes into 64 32 times. I notice that we have a single n in the numerator all over n cubed, which is going to give me an n squared left in the denominator. 32, because that's not a part of n, or the limit, that's just a coefficient, we can pull it out front of the limit. And so we're left with n plus 1 all over this n squared. And then combining like terms, and this is actually in the denominator here, we have this 3. It's multiplication, so just straight across. And then 3n minus this 2n, those are going to cancel. Well, not cancel. It's going to give us 3n minus 2n is just n, and this will give us a minus 1. I notice I can also pull out this 3 and put it in the denominator, so I have 32 thirds. Limit, as n is going to infinity, of, and if I distribute this, this is a difference of squares, we get n squared minus 1 all over n squared. So if we go to look at that as n is going to infinity, we'll get infinity over infinity, but we can either use L'Hopital's rule, or let's divide or multiply by a fancy 1 over n squared divided by 1 over n squared. If we distribute this, we'll see that we have 32 thirds. The limit as n is going to infinity. Well, 1 over n squared times n squared is 1, minus 1 over n squared, all over 1. And now when we take the limit as n goes to infinity, this 1 over n squared goes to 0, and we're left with 1 over 1. So this is 32 thirds times 1, which is 32 thirds. Okay, so each piece was worth 10 points, so problem 1 was worth 20 points total. So problem number 2 has 4 parts, each is worth 5 points. It's straight integration, so integrate as following. First one, we have the integral of the quantity x minus 1 over x times the quantity of x plus 1 over x dx. So if you look at this, we can't just integrate it right away, but we can distribute. And so if we distribute, notice this is a difference of squares. And so this would be the same thing as getting x squared minus 1 over x squared dx. So let's rewrite that a little bit, where we are going to bring that x squared up into the numerator using properties of exponents. So we have x squared minus x raised to the negative 2 power dx. And so now it's in the form that we can go ahead and use the general power rule for antiderivatives. Adding 1 to our exponent, we get 3, divide by our new exponent, which is 3, minus x, add 1 to our exponent, so negative 2 plus 1 is negative 1, divide by our new exponent of negative 1. This is an indefinite integral, so we need to put the plus c here. This negative of negative, so we have really x cubed over 3 plus, because of the 2 negatives, and I can rewrite this with a positive exponent of 1 over x plus c. So I'm okay with you leaving it like that, or you could have gotten a common denominator. So that one was worth 5 points. The next one, we have a definite integral from negative 1 to 1 of 1 all over 3x minus 4 dx. So it's not in the form that we can integrate, but I know how to integrate 1 over u, or 1 over x. So let's use u substitution. Let u equal this 3x minus 4. Taking the derivative of u, we get 1. So we get du equals the derivative of the right, which is 3 dx. We want to solve for dx. Divide both sides by 3. We get dx equals du over 3. We can either change our bounds on our integration now, which I'm going to do, or we could wait and go back and resubstitute in what we had chosen u to be. I choose to change it now. So let's look at when x is equal to negative 1, let's figure out what u would be. So u is going to be equal to 3 times x, which in our case is negative 1, which is negative 3. Negative 3 minus 4, we get u is equal to negative 7. So now let's look at when x is 1. So when x equals 1, let's plug that in to figure out what u is. We have this is equal to 3 times 1 minus this 4, which gives us negative 1. So we're looking at now with our new bounds, so we don't have to rewrite, we are not going to rewrite the antiderivative back in terms of x. So we're going to go from negative 1 to negative 7 of 1 all over what we chose, 3x minus 4, we chose that to be our u value, times du over 3. We can pull the 1/3 out. Taking the antiderivative of 1 over u is the natural log. We need to be careful because we can't take a natural log of a negative number. So you need the absolute values around this u. This is a definite integral, so we don't have the plus c, and we're evaluating that from negative 1 to negative 7. So now we're going to go and plug in our bounds. So this is the same thing as a natural log of the absolute value of a b bound, which is negative 7, minus, any brackets around here, the natural log of the absolute value of negative 1. Oops, and I made a mistake here. This should have been negative 7 down here. And this should have been a negative 1 up here. I flopped them, which changes this a little bit. So this should have been negative 7 down here to negative 1. So plugging in negative 1 minus the natural log of plugging in negative 7, absolute value, 1/3. Well, natural log of absolute value of negative 1. Absolute value of negative 1 is 1. Natural log of 1 is 0. So this is minus the natural log absolute value of negative 7. So natural log of positive 7. So you should get negative natural log of 7 all over 3 as your answer. And that one is also worth 5 points. We have 2c and 2d. 2c says the antiderivative integral of dx all over x natural log of x. And so again, we don't know how to integrate. We don't know how to integrate natural log. And so if you have a natural log in your integral, that's usually what you're going to choose your u to be. And so we're going to choose u to equal the natural log of x. Take the derivative of both sides, we get du equals, well, the derivative of natural log of x is 1 over x dx. Multiply both sides by x, we get dx is equal to x times du. So now looking at the integral, we have the integral of dx. Oops, but dx is the same thing as x over du. Times, or all over x, natural log of x, which we chose to be our u value. So notice our x's cancel. And we're left with 1 over u du. So the antiderivative of 1 over u is a natural log, absolute value of u. It was an indefinite integral, so plus c. And then we're going to go back in and we're going to plug in what we had chosen u to be. Well, we had chosen u to be the natural log of x. And so we have the natural log of the absolute value of the natural log of x. and the absolute value plus c. We need to be careful because we don't know if our bounds are positive or negative, so we should have absolute values around this x also. Okay, that one was worth 5 points. Going over now and looking at part D of number 2. Again, we want to use substitution here. We don't know how to integrate this. We know the derivative of sine of x is cosine of x, and that things would start to cancel. There's more than one term underneath the radical, so let us choose u to equal the radicand, which is 4 plus 3 sine of x. Take the derivative of both sides, we get du equals derivative of 4 is 0 plus 3 times the derivative of sine of x, which is cosine of x, dx. So dx gives us du all over cosine of x. Let's change our bounds. So when x is equal to 0, let's find u. U is equal to 4 plus 3. Let me slow down. Sine of 0. Well, sine of 0 is 0, so we get that u, when x is 0, is equal to 4. Now we want to go back in and we want to see what's happening when x is equal to 2 pi. And we want to find u, so going back in and plugging it into what we had chosen u to be, we get u is equal to 4 plus 3 times sine of, plugging in 2 pi for x. Well, 2 pi, sine of 2 pi is the same thing as sine of 0. And so we get back that u is equal to 4. Well, we saw rules of limits, antiderivatives. If we had the same bound, top and bound, lower bound, this was equal to 0. And notice that our bounds are going to be the same. When we changed them, we can see that they're going to be the same. If you didn't change them, you should get, once you've done all your work, you should get that this integral is equal to 0. So the answer you should have gotten was 0. So one more problem from the test, 2 parts. So find the area bounded between the 3 curves, y equals x. So y equals x, this is this line. We have the curve y equals 1, so that's this curve. And then we have the line y is equal to x squared divided by 9, which is this curve. So part A wants us to find the integration with respect to x. So we need to look at what is the upper curve and what is the lower curve. And so there's 2 different sections of this that we have to look at. So looking at this first piece right in here. So there's different upper curve and lower curve than this piece right in here. And so we're looking at our bounds on our x for that piece in here, which is from x equals 0 to x equals 1. Our top curve in here is y equals x. It's with respect to x, so we're going to write it as x, minus the bottom curve. And the bottom curve in here is this x squared over 9 dx. We're then going to add the integral. And now we're looking at this piece, the second piece. And so our bounds in the second piece are at x equals 1 to x equals 3. Our top function is y equals 1. So this is 1 minus the bottom function. And our bottom function again is x squared all over 9 dx. So now we're ready to take the definite integrals and then sum them. And so the antiderivative of x is x squared over 2 minus, and the antiderivative of this x squared over 9, we'll add 1 to our exponent, it's x cubed, divide by our new exponent of 3, times this 9 down here gives us 27, and we're evaluating that from 0 to 1. Plus, now taking the antiderivative of this 1 minus x squared, the antiderivative of 1 gives us x, minus, and again, the antiderivative of x squared over 9 is x cubed over 27, and we're evaluating this piece from 1 to 3. So plugging in the upper bound first, plugging in 1, wherever we see an x, we have 1 squared over 2 minus 1 cubed over 27 minus, now plugging in 0 wherever we see an x here is just going to give us off 0, or give us back 0. Plus, now we're going to go in and we're going to plug in 3 wherever we see an x, so we get 3 minus 3 cubed all over 27 minus this whole quantity now plugging in 1. So we get 1 minus 1 cubed all over 27. So we want to simplify. We have 1/2 minus 1 over 27 plus, so we have 3 minus, well, 3 cubed is 27 over 27, so that's 1. This is going to give me minus 1. And this is going to give me plus 1 over 27. Since this is addition here, there's no coefficient outside besides the positive 1. We can drop these parentheses and we can start combining like terms. And so I notice this negative 1 over 27 plus the 1 over 27 cancels. I have 3 minus 1 is 2 minus 1, so that gives me 2. And then I have plus 1/2, so 1/2 plus 2. So this gives me back, I think I might just check real quick. I knew something was off. So 3 minus 1 is 2, minus 1 is 1, not 2 right here. So it should be 1. So this is equal to 1.5 or 3/2. So the second part is asking you to integrate with respect to y. Since we want to integrate with respect to y, we need to change our equations in terms of x. So x equals, well, x equals y. Y equals 1. I don't think we need that. And here, y equals x squared divided by 9. So if we multiply both sides by 9, we get 9y equals x squared. Take the square root of both sides, we get x equals plus or minus the square root of 9y. X is equal to plus or minus 3 root y. The thing is that this is above the x-axis, and so this piece right in here has to be positive. So here we have x is equal to 3, and I'm going to rewrite that square root of y as y to the 1/2 power. So we're doing it with respect to y. And so notice our bounds on y are from 0 to 1. The top bound on y is this function, x equals 3y raised to the 1/2 minus the bottom function closest to the y-axis. So we're going to look at this integrating from 0 to 1. The furthest away function from the axis we're integrating is 3y raised to the 1/2 minus the function closest to the axis we're integrating, which is y, and then dy. So taking the antiderivative of 3y to the 1/2, add 1 to our exponent. So adding 1 or 2/2 to 1/2 is 3/2. Divide by our new exponent of 3/2 minus antiderivative of y is y squared over 2. And we're evaluating this from 0 to 1. So multiplying or dividing by a fraction is the same thing as multiplying by the reciprocal. So we have 3 times 2/3 minus y squared over 2, evaluated from 0 to 1. Notice our 3's cancel. Now let's go in and plug in 1 wherever we see a y. So we're left with 2 minus 1 squared all over 2 minus, oops, and I lost my y, didn't I? One to the 3/2 here. And 1 to the 3/2 is 1. So we're still left with 2. Minus, now let's plug in 0 wherever we see a y. And so we have a 0 here and a 0 here, so it's minus 0. We have 2 minus 1/2, which is 4/2 minus 1/2, which is 3/2, which is the same thing that we got when we integrated with respect to x. So integration with respect to y was also worth 10 points. So this portion of the exam was worth 60 points. You want to go through, sum up all the points that you felt that you deserved by your work and how you did, and then put the score on the top of your test, upload that to Canvas, and put it in the assignment for this. Okay, hopefully this was helpful. I look forward to seeing you guys on Monday. Wish you the best of luck on studying for your exams. Take care.